All right, here we go. We're on to Unit 2. Trigonometry final exam review. This is going to be Chapter 2. I think this is the third page in our notes. They're nice and color-coded for us, too, so you can skip right to it. Let's see here. They want us to draw these things in standard position. So if you remember from Unit 2 so long ago, we had two sides of an angle. All right, we had the initial side, which was always on the x-axis. It was always on the positive x-axis. If I can spell right. Initial, I-N-I-T-I-A-L, is that right? I think that's right. All right, we have the initial side is always on the positive x-axis, P-O-S-I-T-I, positive x-axis. All right, and then we have the terminal side. The terminal side, it was just somewhere else. All right, so maybe it's here, maybe it's down below, whatever. Terminal side. All right, this is what we call standard position. It always has to have a starting point on the x-axis, and this was our angle measure. And I went on a rant in the last video that said counterclockwise angles are positive angles. I'm just going to write that one more time. Counterclockwise angles are positive. Why is that? Again, because some old Greek guy said so when they were inventing math. So there you go. Counterclockwise angles are positive. Clockwise are negative, right? So these two angles here, this is what we call coterminal. So we'll get into that a little bit later on, but I might as well do it here. So if I have this angle in standard position, all right here, this is a 120-degree angle, give or take. All right, so I'm going to say this is 120 degrees. All right, I can have a coterminal angle, which means it ends in the same spot. All right, but it's this angle. I'm not talking about the small angle. I'm talking about the big angle. This is a negative 240-degree angle. All right, they end at that same spot. If you wanted to, you could think of another one like this. It's greater than 360, so it has that same starting point on the initial side, and it has that same ending point on the terminal side. That angle is 120 plus 360, and of course, that gives you, what's that, 480? So that orange one is a 480-degree angle. All right. So to figure out a coterminal angle, really all you have to do is just subtract 180 from the original angle, right? So if I take 120 and I subtract 360 from it, I get that negative 240, right? They end at the same exact spot, right? That's what we call coterminal angles. Remember, co is kind of like, I think it's Latin for with or the same, so it ends in the same spot. All right, so that's what coterminal is. They're probably going to ask us for that in this section. So they want us to draw everything in standard position. I can't really use red on this page. So here, I'm going to stick with black. Draw in standard position, then find the exact values for the ratios of 150 degrees. All right, so 150 is over here. Remember, we have our quadrants. We have a 90-degree angle here. We have a 180. This is 270. And then this one is 0 or 360, depending on how you look at it. All right, maybe you're not turning at all. Maybe you're turning a full circle. It's either 0 or 360. So this angle right here is 150. Right? We're on standard position, the exact one. And then they want us to find the values of all 6 trig ratios for a 150-degree angle. So what they mean by that is when we're finding the exact values, we have to have something called the reference angle. So let's go back to this page. The reference angle always gets us back to the x-axis. Right? So in this example, if we have a 150-degree angle right here, we have to think what's going to get us to the x-axis. The reference angle here is 30 degrees because we know this x-axis on the negative side is 180 degrees. So 150 plus 30, that gets us our 180-degree angle. So when we look at this one, they're asking for an exact ratio. What we're going to have to do is we're going to have to look at this piece right here. What is this angle right here? That is a 30-degree angle. Right? Right, so we kind of derived our 30, 60, 90 triangles, but then we had a shortcut and we called it the unit circle. So let me pull up the unit circle. Let's see if I can find that really quickly. We need our trig folder. Here is our unit circle. Right, we had this thing, hopefully you guys are familiar with it. The unit circle, we had all these ordered pairs. Every green ordered pair we said was associated with the cosine. Every blue ordered pair, or every y ordered pair is associated with the sine. And then the orange ones kind of on the outside are associated with the tangents. All right, now, they say we have a 150-degree angle. So these are all of our values here. So the green one here is the cosine. So we know the cosine of 150 degrees is this negative square root of 3 over 2. All right. If you want to look at the sine, that is the y value. So that's a positive 1/2. All right. So the sine is 1 over 2. And then the tangent is that yellow one there, which is negative square root of 3 over 3. Let me try that again. Negative square root of 3 over 3. Right, and that all has to do with kind of the reference angle. Let's see here. All answers exact trig ratio, so we're good. Now we just need the reciprocals. All right, so flip them all upside down. The cosecant obviously is the reciprocal of the sine. Right, so 1/2 flipped upside down is 2 over 1. All right. The other one is going to be, I'm going to keep the negative on the top, negative 2 over the square root of 3, which of course rationalizes into negative 2 square root of 3 over 3. And then the very last one, again, keeping that negative on the top, which gives us negative 3 square root of 3 over 3, which simplifies down to negative square root of 3. All right, so that's what we were looking at. And again, this all has to do with 30, 60, 90 triangles. The unit circle, we have this thing that we talked about in, I think it was 2 videos ago. If we look at the special right triangle for 30, 60, 90, we can get these same exact values here, right? But why not? I've mentioned it, I might as well keep going. All right, so we have a 30, we have a 60, we have a 90. We said this is x, this is 2x, this is x square root of 3. If I look at the sine on this thing, the sine is the opposite over the hypotenuse. That is x over 2x. Look at those x's, they cancel out. And we're just left with 1/2. Right, which is what we had up top. If you want to look at the cosine, right, the cosine is the adjacent over the hypotenuse. That's x square root of 3 over 2x. And again, the x's cancel out. So you're just left with square root of 3 over 2, which is the cosine value. And that should have been a negative on that one because this is going in the negative direction. All right, so this is where the positives and negatives do matter. All right, but anyways, enough about that. This is very much unit circle kind of stuff. All right, so again, solve for theta in degrees if the tangent is equal to negative square root of 3 over 3. All right, well, this one, negative square root of 3 over 3. The tangent, what quadrants is tangent negative in? Well, in order to figure out where it's negative, we have to figure out where it's positive. And we have this little acronym, this little chart thing going on here. We said going counterclockwise. All students take calculus. That's kind of how we remember the order. But this thing tells us where tangent is positive. It tells us where everything is positive. So if we have a negative square root of 3 over 3, that tells us the tangent is negative in quadrant 2 and quadrant 4. All right. So here are the thetas. All right, and they want to know what angles are associated with that. If we want to kind of think about it, it's the opposite over the adjacent. So this is our square root of 3. This is our negative 3. Whereas over here, this is a positive 3, and this is a negative square root of 3. All right, so that's what's going on here. But honestly, with this one, again, it's just more unit circle stuff. Find this value on the unit circle. I'm overcomplicating it as it is. We have negative square root of 3 over 3, right, at 150. So we know theta on this problem is equal to 150. All right. And the second value, theta is equal to, we know it's in quadrant 4. So quadrant 4, right here, negative square root of 3 over 3, that is associated with a 330-degree angle. All right. So that one's done. On the next one, this one a little bit more involved here because we don't have like a perfect number. So what we're going to have to do is we're going to have to take the inverse. But first things first, this is a positive. This is a positive number. So we know cosine is positive in quadrant 1 and quadrant 4. So these are the angle measures that we are looking for. All right. So we have to look at the inverse. All right. So the inverse cosine, actually here, we're going to say the inverse cosine. We'll do it here first. Of this long decimal. All right. So 0.956,304. All right. This is our angle. That's our theta. So what am I doing here? Inverse of that number. My decimal didn't show up. 0.956,304. All right, that's going to give us some number. What is that number? Make sure we're in degree mode, by the way. They want to know degrees, so just make sure you're in degree mode. About 17. All right, so theta here equals 17. So this is a 17-degree angle, and this one is a 17-degree angle. But keep in mind, they are asking for this angle and this one. Right? So the first one, that's your 17. But this one down here is 360 degrees minus 17. Right? It's not a full spin. It's 17 degrees short of a full spin. So 360 minus 17 is going to give us 343. All right, so that is our second value here. All right, so we should always have two answers for theta on these things, and that is 343. All right. Next one. These go quick. All right. Again, this is another one of these charts. All students take calculus. So cosine is positive. We know cosine is positive in quadrant 1 and quadrant 4. we know sine is negative in quadrant 3 and quadrant 4. All right, and they want to know where both of these are true, right? So this and here is both. We want both of these. All right, so just look for the one that matches, quadrant 4. And so they're both, cosine is positive and sine is negative in quadrant 4. All right, so same kind of thing. Tangent, less than, or tangent is greater than 0. So this one is Q1 and Q3. All right, cosine is positive in Q1 and Q4. All right, so again, they are just asking where are both of these true? Well, Q1 is your overlap. Sine is negative. Sine is negative in 3 and 4. And cosine is positive in 1 and 4. Right, so overlap, quadrant 4. Right. And the last one, cosine is negative and tangent is negative. All right, so they're both negative here. Cosine is negative in 2 and 3. Tangent is negative in 2 and 4. And the overlap is quadrant 2 this time. Right. And there we have it. Let's see here. Next page. Can I do this page quick? Draw in standard position. Yeah, why not? We're just gonna press on here. I got 15 minutes before school's over. Draw in standard position, find all the vocab words for 114-degree angle. Now, I don't know exactly where that is, but I can get close. All right, because I know this is 180 over here, and then this is 90 up here. All right, so we know it's going to be somewhere. You know, maybe it's right here. I don't know. It's close enough. Right, so this right here is a 114-degree angle. Now, which quadrant is that in? I haven't mentioned this yet. So again, we do our quadrants, Roman numerals, and of course, counterclockwise, like this. Right, so maybe I have to blame the Romans for that. I don't know. When it asks for the quadrant, they want to know where it terminates. All right, where's the terminating side? That is in quadrant 2. All right, I know I said Q, I used Q2 on the previous page, but really should have been using Roman numerals. Right, the reference angle. What is it going to take to get us back to the x-axis or to the x-axis? In this case, that is going to be a 66-degree angle. All right, reference angles are always positive. All right, so never make a negative reference angle. A larger coterminal angle, all right, that's just going to be 114 plus 360. All right. What is that going to be? 474. They want a smaller one, so that's going to be 114 minus 360. That is going to first and foremost be negative. We're going to say 246. Right? A complement. Ooh, I haven't talked about a complement yet. Complement are angles that add up to 90 degrees. Right? And then supplement are angles that add up to 180. right? So complement. We need 114 plus some number, has to be 90 degrees. All right, so just solve that for x, subtract it over. We're going to get a negative angle, totally fine. All right, so we're going to get negative 24. And then the supplement, all right, just another angle. So we're going to say 114 plus y in this case equals 180, all right? So y is equal to 66. All right, so there's your complements and there's your supplements, right? So we would say negative 24 is the complement to 114, or 114 and negative 24 are complementary angles. All right, and then similarly for supplementary. All right. Here we go. Find the exact value for the 6 trig ratios given the information. All right, terminal side goes through the ordered pair, negative 20, 21. So remember, on the x and y axis, we go to the left and then up. So we know it's going to be up here. So this is at negative 20, 21. All right, that is kind of this point right here. So if we wanted to make a triangle out of this thing, right, we're going backwards 20. We're going up 21 spaces. And then we do have to use Pythagorean theorem to figure out the other side. We call that the radius. So what we're going to do is we're going to have 21 squared plus, and then it's negative 20. Don't forget what's the negative sign, but put it in parentheses. And that gives us 841. We need to square root that number. Don't know what that is. So it's 29. All right, the hypotenuse on this is always a positive number. Because you end up squaring those numbers and adding them together, right? So a positive plus another positive is always a positive number. And then they want us to fill out the ratios here. For theta, this is theta right here. Right? So this should go quick. So the sine is the opposite over hypotenuse. So 21 over 29. Flip it upside down or flip it over. You got the cosecant, which is 29 over 21. All right, and then the next one, you got the cosine, which is the adjacent over the hypotenuse. So negative 20 over 29, right? So this is where that negative does come into play. So just something to be careful about. Flip it over. 29 over negative 20. Doesn't matter that the negative's on the bottom. Generally, we put it on the top. But as long as the fraction's negative, that's kind of what we are after. All right. Then the tangent, of course. The last one here is the opposite over the adjacent. Let me write my numbers correctly. We're going to have 21 over negative 20. And then flip it upside down. You got negative 20 over 21. All right, and that one's done. There's all 6 trig ratios there. They're rationalized. They're reduced. All that good stuff. All right, so now the next one. Given that cosine is equal to 2 over 3. So remember, this goes with the adjacent and the hypotenuse. And then they're saying, hey, it's in quadrant 4. All right, so it's going to be down here. So let's just make our triangle like this. All right, we had the cosine, it's the adjacent. So here's a 2, here's a 3. We need to figure out this value here. And again, Pythagorean theorem, 2 squared plus y squared equals 3 squared. Notice how on this one, y is not by itself. It's not the hypotenuse. In the Pythagorean theorem, the hypotenuse is always by itself. So we have 4 plus y squared equals 9. Y equals the square root of 5. I skipped a step in there. One thing to keep in mind is if I write this, y equals the square root of 5, that's going to give us some wrong answers because it's negative, right? This is going down. Anytime we're going down on the graph, right? And anytime you have a y value going down, it's the negative direction. So make it a negative square root of 5. All right. So just fill them all out. Now we can get everything else. And honestly, we get one for free. The inverse cosine is 3. I'm sorry, the reciprocal of cosine is 3/2. That's your secant. Let's fill out all the other ones. This is our theta right here, always with the x-axis and that radius. So the sine is the opposite over hypotenuse. So you have negative square root of 5 over 3. Flip that. I'm going to flip it upside down and rationalize it. So this is negative 3 root 5 over 5, just to save some room. And then the tangent is negative square root of 5 over 2. So same thing, I'm going to reciprocal and rationalize all in one go. That is negative 2 square root of 5 over 5. Right, and that one is done. So hey, that was all of Unit 2 in a single video. So sorry, that was probably a pretty long video. But 2 down, 5 to go. So we'll see you guys in the next one.